Hi, in this video we're going to talk about the normal model. We'll learn what the empirical rule is and how to calculate probabilities with it. So you might have seen the famous bell-shaped curve before. It's used a lot in statistics and you see it in the media. And I want to give you an idea of where it's coming from. So here's a couple of histograms. The one on the left is systolic blood pressure, and we can see there's a placebo group and an active group. So this is actually looking at two different groups in an experiment, the control group and the treatment group, and measuring their systolic blood pressure. And you can see that the histograms are both roughly symmetric and unimodal. And then the one on the right here, we have National Hockey League player heights. So another histogram, and you can see also roughly unimodal and symmetric, but not perfectly normal. Both of them, or all three of them, have this dotted curve showing approximately a normal curve. So you can see that whenever we take measurements of people or plants or machined items, anything where we're taking a measurement, they tend to follow a normal curve. So we would get this histogram with a roughly symmetric unimodal shape, and then when we draw a curve around it, this is what we get. So this is a model, and there's a saying from George Box saying, no models are perfect, but some are useful. Or actually it's all models are wrong, but some are useful. So this is a model. We don't expect everything to be exactly perfectly lined up according to this normal model, but it is useful and we can use it. So let me explain what this is all about. Here's an example. The mean annual rainfall in Portland is unimodal and approximately symmetric, with a mean of 40 inches and a standard deviation of 8 inches, rounded to the nearest inch. I'm trying to just keep nice numbers for this first example. Label the normal distribution model for this situation. Okay, so first of all, this is how we indicate what our model is, or we define our model. So we always put our variable is distributed as, and then the name or the first letter of the model. And then we want to put in this case, it's the mean and the standard deviation. Another way you'll see it is x is distributed as normal, and we put in our Greek letter symbols with the mean and the standard deviation. So each model has its own inputs or parameters, and this, just like the binomial, the normal model also has two, but they're different. Instead of n and p, it's mu and sigma. Okay, so then to label our graph, what we do is we put the mean in the middle because it's symmetric, so we know the mean, median, and mode all line up right in the middle. And then we label our graph with 3 standard deviations on each side. Okay, so let me write that down. Label 3 standard deviations on each side of the mean. And I'll explain a little bit more about why that is when we get to the empirical rule. But for now, we're going to practice just labeling. Let me get my calculator in the screen here. So an easy way to do it, these are fairly nice numbers, but sometimes you'll have decimals. So I'm going to go 40, put my mean, and I'm going to go plus 8, enter, plus 8, enter, plus 8, enter. And that gives me my 3 standard deviations to the right. So I've got, I'll move this over here, 48, 56, 64. Okay, and I'm going to label my scale in just a minute. Now I need to go 3 standard deviations below the mean, so I'm going to go 40, minus 8, enter, minus 8, enter. And now that tells me I'm going down 32, 24, 16. Okay, and communication is very important in statistics so that people know what we're talking about. So I want to label this annual Portland rainfall in inches. Okay, very important. Label every graph and to put our units on there. Okay, so that is a drawing of a normal model. Okay, so let's keep going, and I want to talk about the empirical rule and what that means. Another name for the empirical rule is the 68, 95, 99.7 rule, and I'm going to show you why that is. Let's go ahead and label our numbers again down here. 40. Oh, sorry, I think that's below the recording window. 40, 48, 56, 64, and going down 32, 24, 16, and annual Portland rainfall in inches. This is from actual data as close as I could get. The mean is pretty right on. It was very challenging to find the standard deviation, but I found some data and calculated it as best I could. So here's our same normal model that we have, and I want to explain the empirical rule. So what this says is about 68% of the values fall within one standard deviation of the mean. Okay, so that's from, we've got our standard deviations drawn on here. From here to here is about 68%. And you can kind of see it is a big chunk. It looks like it's probably over half. It's a little hard to tell because the shapes are different. It's a little hard to compare the areas. But this does look like quite a large chunk of the curve. So this is about 68% of the area or the probability. Okay, and then it says about 95% of the values fall within 2 standard deviations of the mean. So I'm going to draw in these lines here, and I'm going to go up above. Between those 2 pink lines is about 95% of the values. So now we're really getting to almost all of the values, 95%. And then the third part, 99.7% fall within 3 standard deviations of the mean. This one I'm going to go down below here. From there to there, make sure you can see that. From there to there is about 95% of the values. Oh, sorry. That's not the right number. 99.7% of the values. Okay, so this is exactly why we label 3 standard deviations on each side of the mean, because that covers not completely 100%, but almost 100% of the values will fall within 3 standard deviations of the mean. So this is called the empirical rule, or the 68, 95, 99.7 rule, which is kind of a mouthful. And this is why we label 3 standard deviations on each side. We don't need to go any further because there's barely any area outside of that. Okay, so this also gives us a guideline for outliers. So it says a value that is more than 2 standard deviations away from the mean is considered unusual. So out here, if we have a value out here that's considered unusual. Might be on the high side or the low side. So you could say an outlier. And then anything out here, because there is just a tiny bit of the curve that keeps going, anything out here is very rare. If you're more than 3 standard deviations from the mean, you're quite rare. So very rare. Okay. On the next page, we are going to use this empirical rule to find some probabilities. Okay, so let me switch my page here. I'm going to keep using that page as a reference. Okay, so finding probabilities using the empirical rule. Okay, so what I'm going to do is I'm going to draw lines for those segments. And we're going to use the empirical rule to calculate calculate and write in the probability in each of these segments. So I'm going to write my numbers in again. You might be tired of writing these. 40, 48, 56, 64, and then 32, 24, 16. Annual rainfall in Portland in inches. Okay, so we're going to use our empirical rule chart that we just made, and if the middle two, if I also draw a line in the middle here, these middle 2 sections add up to 68% overall. So if I divide that by 2, I'm going to get 34%. And each of these middle sections is 0.34 or 34%. Okay, so let me write down my steps here. 0.68 divided by 2 is 0.34. You can double check it if you want. Okay, great. Now I want to find out what is the probability in each of these spaces, okay? Well, we know this is 68, and if we go out the next standard deviation, that's 95. So I need to figure out what is only this part, okay? So that means I need to subtract 0.95 minus 0.68. If I subtract this part, that'll tell me how much is only in this part. Okay, and that's 0.27 or 27%. Now I need to divide that by 2 because I get half on each side, and it is symmetric, so that's a nice feature. So divided by 2 is 0.135. So I'm going to write 0.135 in each of these spaces. Okay, are you kind of seeing the pattern on how to do this? If you want to try these 2 spaces and then the very outside spaces, you can pause the video and try it yourself. Or if you want to keep doing it with me, you can keep doing it with me. So 68, 95, 99.7. So now I'm going to take 0.997 minus 0.95. That will give us these 2 extra little spaces right here. Getting smaller and smaller, right? 0.997 minus 0.95 is 0.047 divided by 2. 0.047. 0.047 divided by 2 is 0.0235. Can't quite fit that in there, so I'm going to put an arrow. 0.0235. Okay, and now we do have a very tiny amount that is outside of 3 standard deviations. You might be wondering, well, what's the total add up to? If you said 100%, you're right. Our area in any model has to add up to 100%. So 100 or 1.0 in decimal form minus 0.997 is 0.003. And then 0.003 divided by 2 is 0.0015. So 0.15%, less than 1%. 0.0015. Okay, now I need to put some arrows again. There, you can see this gets very, very close. It approaches the 0 line, or the x-axis, but it doesn't actually touch it. 0.0015, 0.0015. Okay, so if we add all these numbers up, that'd be a good check to do. If we add all these numbers up, they should add up to 1.0 or 100%. And this is a handy guideline. Remember, the empirical rule is these are approximate numbers, but it's kind of a handy guideline to know. So now we can use these to calculate percentages or probabilities. What percentage of the time is the annual rainfall between 32 and 48 inches? Okay, so I'm going to write my probability statement. Between means I'm going to have 32 is less than or equal to x is less than or equal to 48, or the way I read it is x is between 32 and 48, and that is going to be 0.34 plus 0.34 equals 0.68. That's the decimal form. This one asks for a percentage, so I could say or 68%. Now, we could have done that without adding these two together, because we already know by the empirical rule that one standard deviation away is 68%. So you might have done it that way too. Okay, let's do another one. What's the probability that the annual rainfall is more than 48 inches? Okay, so I need to see where 48 is. It's right here. Probability that x is greater than or equal to 48. And something you might be wondering about is this more than. Technically, it's not greater than or equal to, right? It's just greater than. So I'm going to write it like that, but mathematically there isn't a difference between these two questions, because this is a continuous distribution. In the binomial model there was a difference, because that's a discrete distribution. In the binomial model you have the bars, but this one is a continuous curve. So think about the area being a rectangle. This is like a rectangle or a shape, because this is a curved side. But if we just have a single value, the probability is actually 0 at a single value, because there's no width to that shape. So there's no area just on a single value. So that's why if I write greater than or equal to, there's no mathematical difference in a continuous distribution. So I usually match my symbol to the wording that's in the question. So more than 48 is greater than 48. And now what I need to do is find 48, which standard deviation it lies on. And then I'm going to add up everything to the right. So this is going to be 0.135 plus 0.0235 plus 0.0015. Okay, so I'm going to add these up. 0.135 plus 0.0235 plus 0.0015. 0.16. This one asked for a probability, so I'm going to keep it in decimal form. Okay, now when you go to do problems, you're going to have a different mean and a different standard deviation, right? So these numbers, 0.34, 0.135, these numbers on the inside are the same no matter what normal distribution you have. Okay, what's going to change is the scale down below. If you have a if you have a mean of 10 and a standard deviation of 1, it's going to go 10, 11, 12, 13. So when you get to these problems, you're going to make your drawing, put in your numbers, and then these numbers will always be the same. Okay, so it's the same shape whether you stretch it out or you squish it up. It's really interesting. It's the same proportions of the shape. Okay, so now let's go to part C. What percentage of the time is the annual rainfall 24 inches or less? So probability X less than or equal to 24, 24 or less, so this is less than or equal to. And if you want to try the last few, pause it and then check your answers. 24 is right here, so I have two numbers below that, so I'm going to add those up. 0.0235 plus 0.0015 0.025. Or move it over two places, 2.5%, because this one asks for a percentage. So in my open math, just watch real carefully if it's asking for a percentage or a probability. Okay, so far so good. Let's go up to D and E. What's the probability that the annual rainfall is 56 inches or less? X less than or equal to 56. Okay, now let me put my drawing back here for a second. Sometimes there's some shortcuts, right? 56 is right here, so I know I need to add up all of these. Well, one thing that's handy is half of it is 50%. So I could just add up 50% plus 34.34 plus 0.135. Or I could take 100% and subtract these other two. Okay, so use some shortcuts to help you out so you don't have to add up every single number. I'm going to do the 50%, 0.50, because everything less than 40 is 50%, plus 0.34 plus 0.135. .975. Okay, just for fun, I'll do it the other way too. Or 1 minus 0.0235 minus 0.0015. Should come out to the same answer. Phew, it did, 0.975, okay? So, last part, E, what is the probability that the annual rainfall is 54 inches or less? Okay, 54 inches, let's look on here. Bring this down again. 54, okay, now this is a problem because we don't have 54. It doesn't line up with one of our standard deviations. Okay, now you might think, okay, well, it's partway in between here. Can we estimate? But remember, this is not a straight line. It's not a linear. So if it was halfway in between, we couldn't cut it in half because there's more on this side than on this side. Okay, so this is a lead-in to the next video because with the empirical rule, we can only find certain probabilities. We can only find probabilities involving these exact numbers that are an exact multiple of the standard deviation or the mean. Okay, so we cannot do this one yet, but rest assured there is a way. So we will do this in the next video. Okay, thanks for watching, and I'll see you in the next video.